Alright, so this is how you solve combination circuits, guys. The first thing you'd want to do is you want to find any series circuits, any series resistors that are in this whole circuit here. So we have R3, R6, and R9, and they all together basically form one big resistor along this section of the circuit. And then R5 and 7 also create a small section here, which is basically just a larger resistor. So once we've found everything that we can add up in series, we want to start on with our parallel circuits. So we take the total of R3, 6, and 9, which is 22, and then we do it in parallel with the total of R5 and R7, which ends up being 74. So when we do our, I don't know if it's product over sum, but we do our, I'm just going to call it product over sum equation here. We do 1 over 22 plus 1 over 74 to get 16.958. So that's basically this entire section of that combo circuit completed at this point. And we have this R2 up here, which is in series with the rest of all this, after we've solved for the R total down there. So combining R2 with R3, 5, 6, 7, and 9 at this point, we get a total of 31.958, because the resistor for R2 is 15, so we just add those together. And then we have the stray resistor of R4 just chilling in the middle there. We end up doing another parallel circuit equation for these two here. The entirety of R2 to R9 there in this section, plus R4. So we have 31.958 and 86. So we do the 1 over 31.958 plus 1 over 86, which gets our total resistance for this entire section here, R2, 3, 4, 5, 6, 7, and 9. And after that, we would add them in series with R1 and R8, since these are both not on not on a parallel circuit, it's just in series with the rest of it. So we take the total of R8, which ends up being 12, the total of R1, and the combined total for R2, 3, 4, 5, 6, 7, and 9, which ends up being 21.74. Adding those all together gets us our final answer of 73.74 ohms. At any point, you can pause and rewind and all that shit. I'm sure you'll be fine.